All right, for our last problem, as part of a class project at a large university, Amber selected a random sample of 12 students in her major field of study. All students in the sample were asked to report their number of hours spent studying for the final exam and their score on the final exam. A regression analysis on the data produced the following partial computer output. Amber wants to compute a 95% confidence interval for the slope of the least squared regression line in the population of all students in her major field of study. Assuming the conditions for inference are satisfied, which of the following gives the margin of error for the confidence interval? So I wrote down some kind of information that we're going to need. Margin of error. Okay, this is going to be our critical value times the standard error. In this case, we're talking about population mean, and so we are going to use our t-distribution. Okay, the slope, that's our study hours coefficient. That's that 2.697. And if you look right next to it, that's going to be the standard error of the slope, which is 0.745. So if we want to find the margin of error, we need to take our critical value times the standard error of the slope. Okay, if you look at our answer choices, all of the critical values are going to be 2.228. The difference is we need to know what our standard error of the slope is, and really, guys, we get it straight from that printout. It's that 0.745. So in this case, our answer is just going to be A. All right, for 33, it says a mathematics competition uses the following scoring procedures to discourage students from guessing, choosing an answer randomly, on a multiple choice questions. For each correct response, the score is 7. For each question left unanswered, the score is 2, and for each incorrect response, the score is 0. If there are 5 choices for each question, what is the minimum number of choices that the student must eliminate before it is advantageous to guess among the rest? So for this one, all right, what we're going to do, all right, so I'm going to say that X is the points for a correct response, right? So if 5 choices remain, so you can't eliminate any of them, then the probability of X, with X being 7 points if you get it right, or 0 points if you get it wrong, right? If there's 5 choices, then that means you have a 20% chance of guessing correctly, which means there's an 80% chance of getting the wrong answer. And so if we found our expected value when there's 5 choices remaining, we take 7 times 0.2 plus 0 times 0.8, and we have an expected value of 1.4. So in this case, we would have been better off just leaving it blank because we would have gotten 2 points for a blank response versus an incorrect response, right? So if we did the same thing, but this time we did it for 4 choices remain, all right, so we still have X. You can get 7 points for a correct answer, 0 points for an incorrect answer. All right, now if 4 choices remain, so you were able to eliminate 1, then this time there's going to be a 25% chance of you getting it correct, which means that there's going to be a 75% chance of you getting it incorrect. So if we find the expected value on this one, we're going to take 7 times 0.25, and we would multiply that by 0 times 0.75, which we know is just 0. All right, but that gives us 1.75. And so once again, we would be better off leaving it blank because we would have gotten 2 points for leaving it blank. All right, now if we do this one more time with 3 choices, all right, then this time if we do 3 choices, I'm going to do that in a different color. For 3 choices, all right, we have the probability is going to be 1 out of 3 to getting it correct, which means it's going to be 2 out of 3 for getting it incorrect. And so our expected value is going to be 7 times 1/3 plus 0 times 2/3. All right, and if we solve for this one, we get an expected value of about 2.33. All right, so in this case, we are expecting to get more than 2 points, so we are better off guessing than we are leaving it blank. All right, so the question says, what is the minimum number of choices that the student must eliminate before it benefits them, right? So if they eliminate 0, it doesn't benefit them to guess. If they eliminated 1, it didn't benefit them to guess. But when we eliminated 2 questions, then it actually benefited them. So our answer is going to be C. All right, question 34, the probability that a new microwave oven will stop working in less than 2 years is 0.05. The probability that a new microwave oven is damaged during delivery and stops working in less than 2 years is 0.04. The probability that a new microwave oven is damaged during delivery is 0.1. Given that a new microwave oven is damaged during delivery, what is the probability that it stops working in less than 2 years? All right, so we want, all right, the probability that it stops working given that it was damaged. All right, so to solve for this, we need to take the probability that it stops working and it was damaged, which they gave us that as 0.04. So I'm going to take 0.04 and I'm going to divide that by the probability that it was damaged. Okay, just damaged alone, and they gave that to us as well as 0.10. All right, and so when we solve this, we end up with 0.4 as our answer. And so in this case, we will end up with D as the correct answer. There's a 40% chance that it stops working given it was damaged. Perchlorate is a chemical used in rocket fuel. People who live near a former rocket testing site are concerned that the perchlorate is present in unsafe amounts in their drinking water. Drinking water is considered safe when the average level of perchlorate is 24.5 parts per billion or less. A random sample of 28 water sources in this area produce a mean level of 25.3. Which of the following is an appropriate alternative hypothesis that addresses their concern? Right, so they are concerned that there is too much of this chemical in their drinking water. So this is going to be one-sided because they're looking to see if there's more than the safe amount, and the safe amount is this 24.5. So our alternative hypothesis for this one would be that the mean is greater than the safe amount of 24.5, and that's going to be D. Looking at 36, the computer output below shows the results of a linear regression analysis for predicting the concentration of zinc in parts per million from the concentration of lead in ppm, parts per million, found in fish from a certain river. Which of the following statements is a correct interpretation of the value 19.0 in the output? So right here is our 19.0. This represents our slope. And so in the context of this problem, we would say that on average, there is a predicted increase of, it's an increase because our slope is positive, right? And so it's an increase of 19 parts per million in concentration of zinc for every increase of 1 parts per million in concentration of lead found in the fish. And so our answer for this one is going to be B. 37 says there were 5,317 previously owned homes sold in a western city in the year 2000. The distribution of the sales prices of these homes was strongly skewed right, with a mean of $206,274 and a standard deviation of $37,881. If all possible simple random samples of size 100 are drawn from this population and the mean is computed from each of these samples, which of the following describes the sampling distribution of the sample mean? All right, so for this one, we've got to figure out what the mean of the sampling distribution is. All right, and we also need to know what our standard deviation of the sampling distribution is going to be. All right, so the mean of the sampling distribution is always equal to the population mean, all right, which they gave us as 200 and 6,274. All right, now for our standard deviation, we are going to actually need to calculate this one. We're going to take the standard deviation of the population and divide it by the square root of the sample size, which in this case is going to be the $37,881, and we're going to divide it by the square root of 100. So our standard deviation is going to be $3,788, all right, and 10 cents. Okay, our sample size is 100. We can say that this is approximately normal because our sample size is greater than 30. So we're going to say it's approximately normal with a mean of $206,274 and a standard deviation of $3,788. Answer A. 38, a physician believes that the exercise habits of East Coast adults are different from the exercise habits of West Coast adults. To study this, she gathers information on the number of hours of exercise per week from a random sample of East Coast adults and a random sample of West Coast adults. Which of the following might be an appropriate null hypothesis for this study? All right, in this case, she just says that she believes the exercise habits for East and West Coast adults is different. All right, so our answer for this one, okay, an appropriate null hypothesis would be the average number of hours of exercise per week for East Coast adults is the same as the average number of hours of exercise per week for the West Coast adults. A, C, and D would be potential alternative hypothesis depending on what she was looking for. All right, remember our null hypothesis is always that there's no difference.